Hello? Hello?
Amanda, are you there?
Yes.
Okay, sorry. I don't know what happened. Okay.
Okay, me either. Um, can you guys see me?
No.
Okay.
I think this too. Oh. Okay. Okay, now we can see you.
Okay, cool.
Okay. So let me open up our group. I think it says live, so hopefully it's working.
Okay. Also, for this week, hold on a second. Okay, for this week, there's not a group discussion, so should we post the link and everything in last week's discussion?
Yeah, or I guess I could just email it to them.
Okay.
Okay. And then for our project
Uh-huh.
this week, I can't remember who's in charge of submitting it.
Oh, I am. So, for this week, isn't it describe the data?
Yeah, I think it is. So, do we just need to send you what we collected?
Yeah, so I think you guys send me all of your data, like whatever you turned in last week, and
Okay.
then I'll put it all together and describe it, and then I can email it back to you guys so that you can check it and make sure.
Okay, perfect. We'll do that tonight then.
Okay. And then if you send it to me tonight, then I could email it back to you guys by tomorrow because I'm trying to get all my homework done by Wednesday this week.
Okay, perfect. Yeah. Because we're going to be in Rexburg on Thursday, so I don't know. We're trying to get all our homework done too, so that'll be perfect.
Okay. Okay, cool.
So, okay.
Okay, so let's go. You want to start with the first question? Or the second question, I guess?
Yeah.
All right. So it says, deciding which hypothesis test to use. Here is a list of hypothesis tests we have studied so far this semester. For each of questions 2 through 6, identify the one hypothesis test that is most appropriate to the given situation. You may use a hypothesis test once, more than once, or not at all. In the answer box, type in the letter A, B, C, etc. Okay. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school and undergraduate degree, master's degree, doctoral degree, of people who managed successful startup companies in the United States and Korea. You want to determine if education level differs between managers of successful startup companies, differs between these two countries. Which hypothesis test would be most appropriate for this analysis? Why?
So I said C, paired samples t-test, because you're trying to figure out the difference, and that's the one in Excel that shows each column and then how much they differ.
Okay. Are you doing just capital C, lowercase c, or what? Or
I'm just doing lowercase because that's how it showed in the example. Type in the letter A, B, C, etc.
okay.
So I'm just putting a lowercase c and that's it.
Okay, that works. Let's see. You want to read number 2, Brittany?
Yeah.
Or number 3?
Yeah. A human resource manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger or over 40 years. They also reported the number of employees in each group who were terminated. You want to determine in both groups if both groups were treated equally. Which hypothesis test would be appropriate for this? That one be?
Okay. Close the 2 groups. So we have.
Wouldn't that one be paired too?
Okay.
Well, I was actually kind of confused on that one because so there's 2 groups. There's 40 years old or younger and then over 40 years. So there's 2 groups. And then they reported the number of employees in each group who were terminated. So
Maybe ANOVA?
you want to determine if both age groups were treated equally.
Go to your notes.
Wait, I was just looking at the first one though, and it said there's only one set of data compared.
Wait, no, because it was comparing the United States and Korea.
Oh, okay.
So
But then would that be a 2 proportion test because it's comparing education levels instead of numbers?
Wait a second. Determine if the education level differs between managers of successful startup companies between the 2 countries.
I don't know.
okay, so you have successful startup business in the United States and Korea compared. So you have
I mean, I could see it being paired, but I could also see it being two proportion. That's why.
So if it's doing...
So what's the definition of samples? Sample, quantitative. It's quantitative because we want to know.
Oh, it is quantitative.
Is it quantitative or categorical? It's quantitative because it wants to know educational, or is it you want to determine if education levels differs between managers, or is that categorical? I thought you knew.
I just thought it... I think it's C because you have to compare the two and it wants to know the difference. And then, like, in Excel, the paired sample t-test, it shows the two different... Like, it would show for the United States and then for Korea and then how much they differ.
Okay, yeah. Okay. So then for the next one, we're wanting to know
if the two age groups were treated equally. So there's the 40 and younger and then the 40 years olds.
So would that be considered categorical or quantitative?
Well, you're trying to figure out... It's like, I'd say categorical because you're going off of how they were treated. Categorical. So maybe it's the two samples.
Hold on a second. I think let's skip those two real quick. Let's go to number 4 and see what this one says. It says a survey was conducted by a group of state lotteries, a random sample of 2. So we know. So I think the first two actually. I think those first two are going to be categorical because it has nothing to do with numbers. This next one, number 4, comes down and you get numbers here. That's going to give you a quantitative. You know, that's going to give you a numbers score. Right? So you know that's going to be quantitative. So number 4, you know, is going to be quantitative. And 2 and 3, it doesn't have any numbers and it doesn't have any... So I'm almost thinking those two are going to be categorical because it doesn't have any statistics of how many adults they took and what percentage of adults, how many, you know, that kind of stuff. So
Well,
you're not
that
going to...
makes sense.
Okay. Because that's what I was thinking. Okay. Yeah, because those first two are kind of confusing me. So should we come back to those two after we go through, or do you want to, or should we?
Well, okay, do you guys have that statistical flow chart?
Yeah.
Are we supposed to use that flow chart for these ones? Because it's not saying, it's just saying what kind of samples, how many samples, but it's not saying, like...
Right, so you had to fill it. So we went in and filled it in. So, like, if the, what's that called again?
Sigma.
If the sigma's known, then it's a one-sample z-test. If the sigma's unknown, then it's a one-sample t-test. The dependent sample is a paired t-test. And then the independent sample is an independent sample t-test. 3 plus samples is ANOVA. 1 sample under categorical is 1 proportion. 2 samples under categorical is 2 proportion. And then the row X column table is the, is it the chi or the chi?
Chi squared.
Chi squared.
What's 2? We haven't done 2 quantitative.
No, that's going to be in the next chapter. So that's why I think it's important to ask yourself, you know, while you're doing it, is it going to be quantitative or categorical? Because then you almost know which one to look under.
Wait, so then so then row by column table is the chi-square, but then the two quantitative variables is
We
that
won't learn. We won't. When I watched a
also
video,
the chi.
well, he said that the two quantitative variables we won't learn until the next chapter.
Okay,
So
that
it's not
makes
on
sense.
this
I was
test.
like, I don't remember learning about that.
Yeah, because I was looking at it too. I didn't know what it was, but when I went back to his video, he said it's not going to be.
So let's do 4. Let's do 4 and see what we get from this one. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? So we have a sample of 2,000 people, and we have data of, we only have one set of data, right? A total of 248 people, so one set of data. And you want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 40.
So we know it's quantitative.
That would be once.
Yeah, we just need to know is the sigma known or unknown?
The sigma is the standard deviation, so it's
Right.
one test.
Sample.
Because it doesn't give us a standard deviation. Yeah.
Yeah, maybe.
Which is what, B?
Yeah.
So then, one sample. The sigma, I don't think the sigma is known because it doesn't say standard deviation. So
Right.
wouldn't it be one sample t-test?
Yeah.
Yeah.
Yep.
That's what.
So B. So going back to 2, would that be, since 2 and 3 are categorical, that one would be,
Which one are you on?
number 2 in the group meeting. So there's 2 samples of United States and then Korea. So I think that would be the 2 proportions, the test of 2 proportions, G.
Yeah.
Okay.
And then,
Yeah.
and then I think 3 would be the chi-squared H, because that's talking about the 40 years and younger and then the 40 years old, and then from each of those it's talking about the number of employees in each group.
What other things?
Okay. Yeah.
Okay, so it says chi squared is row X column table.
Yeah.
Yeah, row by column table.
Did they give us columns?
Well, they didn't give us one here, but I could see that being a column. Okay, perfect. So then, and then we got B for 4, so now we're on 5.
Okay. A student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first and the other lock turned clockwise twice. They asked 25 students to participate. Each student was given the lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open, which hypothesis test would be most appropriate. So there was one sample of the 25 students.
One sample. There was one sample.
So
Or wait,
Yeah, there's one sample because there's only 25 kids, or
Yeah.
right?
Yeah. I would say it's F.
Yeah, it takes the same.
F is test of one proportion.
Or is it that it gives it?
Well,
Or does it change that it's given that?
You get two different results.
No, it's one test, and you could get two.
wait, but maybe it's two proportions because there's 25 students, but then, oh wait, never mind. Each student was given the combination to each lock. Okay.
Yeah. I
Yeah,
think it's
so-
one proportion.
Yeah, I think it's F2.
Okay.
One
Brittany?
proportion.
Yeah. Weight gain during pregnancy of a woman is an important indicator of infant health. A simple random sample of pregnant women in Egypt, Kenya, and Mexico were used to determine if weight gain during pregnancy differed in these three countries. Which hypothesis would be appropriate for these?
You have 3+.
Yeah. So would it be the G one again?
I know, but
No.
Wait, dealing with weight gain, would that be quantitative? Because weight is numerical?
Possibly. Yeah, so maybe it is a NOVA.
I think so because they want to know.
Okay.
Yeah. So I'd say E.
Okay. And then read the directions.
Okay. And the directions. Describe which confidence interval to deciding which confidence interval is to use. Here's a list of confidence intervals we have studied so far this semester. For questions 7 through 10, identify the one confidence interval that is most appropriate for the given situation. You may use a confidence interval once, more than once, or not at all. In the answer box, type in the letter ABC. Okay. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that he appraises that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for the study? Ooh.
So, let's see. There's two appraisers, and they're comparing
6 properties.
their values.
So +4 confidence interval for 2. Yeah, we've never had it explained this way. The upper level.
So maybe it's I think it's
Hold the book.
Amanda, are you still there? Just leave.
Amanda, are you there?
Yeah.
Okay. Okay, so we're looking up, I don't know which one. Which one did you say maybe 7 would be?
I set confidence interval for 2 proportions because this one would be categorical because it's talking about the properties that both appraisers are valuing. So or do you think it would
Yeah, I
be
can see that.
or do you think it would be quantitative because they're comparing prices and that's numerical, the prices?
That's, I don't know, okay.
Let's read it. Let's see.
To make sure this case, the bank evaluates 6 properties that both appraisers had recently valued.
I think it would be quantitative and then paired samples T confidence interval because they have to pair them and make sure there's no difference in between them.
Yes, that makes sense. That makes more sense.
So I'd say C, the paired one.
Okay, perfect. Okay, we'll go with 8 now. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied or very satisfied with their career paths was reported. The same data was also reported for accounting majors. You decide to construct a 95 confidence interval to see if the observed difference is significant. Which confidence interval would most be appropriate for this study?
So there's 2 samples. It's categorical because it's either satisfied or very satisfied. It's
Right.
not. So then the plus for confidence interval for 2 proportions.
Yeah, would it be F?
Yeah, that's what I think.
Because it's a 2 proportion and not a 1 proportion.
Yeah.
It wants to know psychology and accounting majors.
Oh, okay. I didn't get the accounting part. Okay. Yeah. F.
Mine's frozen, so.
Okay. So number 9. O'Hare International Airport in Chicago has a reputation for having a large proportion of its flights being late. You design a study to see if this reputation is deserved. You find that the average on-time rate for all international airports in the U.S. is 70%. You collect data and determine the on-time rate for O'Hare. You decide to construct a confidence interval to compare O'Hare's on-time rate to the national average. Which confidence interval would be most appropriate for this study? So you're doing on-time, so it's going to be 1 proportion test or 2 proportion, right? Because it wants to know on-time, right? If it's on-time or not on-time. Is that right?
Yeah.
Yes.
So we've got, so it's going to be interval for 1 proportion or 2 proportions. And it wants to know Chicago's, I would just say 1 proportion.
Yeah, because it's only doing that one airplane flight.
Yeah. If it were doing more airports.
So then it would be E
Yeah.
for one proportion. Okay.
Okay. Amanda, do you want to read the Oreo one?
Yes. Okay. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? So if they're measuring it in amount, would that mean it's quantitative because they're measuring it in number? How much more?
Yeah. Yeah, I think so.
And so they're comparing them, so I would say C, paired samples, T, confidence interval.
Yeah.
Because they're just comparing the two.
For example, T confidence interval.
Yeah.
So C.
Yeah. Okay, so 11. Which one of the following best defines the notion of the significant level of a hypothesis test?
I put A, because if you look up the definition of significance level, it's the probability of rejecting the null, whether it's true or not.
Yeah.
Perfect. And then, which one of the following best defines the notion of p-value of a hypothesis test? Isn't it B?
Yeah, that's what I put.
Okay, 13 is suppose you create a 95% confidence interval for a mean, and you get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 95% of the data are between. Is it A, or is it?
I said C because they're 95% confident that the true mean is between 10 and 20. So that would mean there's a 95% chance that the true mean is between 10 and 20.
Or is it?
Wait, I thought we didn't use the word chance, though. That you weren't supposed to use the word chance.
95% of the sample means. I like that. I like B. 95% of the sample means are between 10 and 20. So it's not a 95% chance, but 95% of the sample means.
Yeah, okay. I think it's B then. B, that would be right. Yeah, because I think when we put chance before that, we got it wrong.
Okay.
That's not.
Yeah, I think B sounds good.
Okay.
Okay, 14 through 16. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportions? Okay, so this is where we need to figure out.
So is this the? I think this is P equals X over N.
You take a random sample of 100 results from a town to determine the proportion. What is the mean of the distribution of sample means?
We're not going to eat.
Do you know where our red notebook is?
So I think it's asking what x is, so then to find x, won't we do n times p? 0.30 times 100?
Yeah, I think so. So it'd be 30.
Yeah, that's what I put.
So and then it's wanting to know the standard deviation of the sample mean proportion.
I have no idea what.
Yeah, so if you enter that information into the, if you enter into the one sample z-test for a proportion, the categorical Excel, then,
So we need to open that up. Hold on.
yeah.
What is it?
Was it behind the shower?
No.
Or in the pile? Or...
That was always on the table.
So it's categorical, so we would use the categorical one.
Yeah, categorical data analysis and then the one proportion, because we're just entering the information. X is 30, N is 100, and then the null is 0.3. And then number 15 is asking the standard deviation of the hypothesis test.
Okay, so this is one proportion. We decided that X is 30. Sorry, and N is 100. And then the null is 0.30. So then for number 15, we look for the standard deviation, which would be B.
Yeah.
Okay. So then what is the probability your random sample?
0.046.
Yeah, perfect.
So then to do that, change
So
the
then
null
what?
to 0.25.
The null to 0.25.
And then we will change it to less than the type of test.
And then we want to know the probability.
Yeah.
So take that z-score and put it in the probability applet.
Wait a second. So 0.25. No, isn't the probability just the p-value?
Yeah.
Because if you put, yeah, because then that would be the same as putting it in the applet.
Yeah.
So then, I got 0.876 for p-value.
Perfect. That's what we got as well.
Okay.
For questions 17 through 21, use the following information. I don't know what that is. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. 1,563 subjects in the experimental group received Acupril. 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a 95% in confidence interval for the P1 minus P2.
Okay, so we would use a 2 proportion, right?
Then we'd enter
Okay.
the information. So the first group is the 1563 for N1 and then 61 for X1.
Well, sorry, we couldn't really hear you. You were breaking up there, but so it says you want to take the true proportion of people who experience dizziness. So we want to take the amounts of those who are dizzy. So I think it'll be 61 minus 15, right?
What's X1?
P1.
I know, but I need to put X1 and N1, X2, N2.
Oh.
Wait, what?
Amanda, can you hear us?
Yeah. Can you hear me?
Okay, we're just a few seconds delayed is all. Yeah, we're a few seconds delayed.
Oh, okay.
So what would you put in for X1? 51. 1563. And then N1.
And 61.
Okay.
I put 6.
Is 579. And N2 is... Okay, Amanda, what did you put for X1, N1, X2, N2?
$16, and then the N2 was $579.
So we put 1563 in X1.
No, 1563 goes in N1 because the X is how many had success, and then the N is the sample.
So 1563 in N1 and 61 in X2. I mean X1.
No. Yeah.
And then in X2 I would put 15.
Yeah.
In N2 I would do the sample size, which is 579.
Yeah.
Okay. And then a confidence level of 0.95.
Hmm.
And then the P, or in the test type, did it say anything about that?
That's what I'm trying to look at.
I want to say, would you do not equal to just because it doesn't say greater than or less than anywhere?
Yeah, I think it's equal to or not equal to. Yeah. That's... So then for 17, after filling that out, for the confidence interval,
Yeah.
I got the one that's C, the negative 0.004.
Perfect. That's what we got as well. And then it says perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion.
So that's pretty much what we just did.
Right. Yes. So using the significance level of 0.05. So wouldn't it be B?
Yeah.
No,
Mhm.
it would be B, I mean.
Yeah. Isn't that what you said? B?
Yeah, B, sorry.
Okay.
And then the value of your test statistic is Does it give us a test statistic? I don't see it.
Yeah, the test statistic is the
You
Z
wrong one.
score.
Oh, okay. So then it would be D.
Did you say D?
Yeah.
Okay, yeah.
And then 20 would be D as well.
Yep. And then 21, since the p-value is greater than the level of significance, I put no because we failed to reject the null.
Then no, that one, right? So that would be E.
Yes.
Okay, perfect. So now it looks like we're going to use the chi-square for the next.
Yes.
Do you want to read it, Andrew?
Yeah. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypotheses for this study are null, being a morning or evening person, is independent of age. Null is being a morning or evening person is dependent on age. The results of the survey are given here. Use this table and information above to answer questions 22 to 25 with a level significance of 0.05. Conduct a test of independence. Calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied.
Okay, so then for 22 and 23, we just enter that information to the table, and then we get that from the chi-squared test.
Yes.
Okay.
The p-value is greater than. So we reject the null. P-value is greater.
The p-value,
Is low. The next reject the null.
p-value
So
is
she-
different. So it's higher.
So no, the p-value is greater than.
How's that? What'd you
No,
get?
it's
How did you get that without penalty? How did you get this one without penalty? How do you get it without?
Okay, did you guys enter your information already?
Yeah, so did you get 22?
Yeah, so for 22, I got 6.580.
Yes.
which is
Okay.
letter A. Okay.
And then for 23, we got B.
Wait, B or D?
I got B.
0.009?
B? Wait,
Oh.
I got D, 0.087, if you round.
Should we round?
Oh, yes, because you're rounding to the third. Sorry, I was rounding
Yeah.
the wrong one.
Okay.
Yeah, so it's D. Yeah, that's right.
Okay.
Okay.
So because it is higher,
Yeah, the p-value's higher, so we would
fail to reject.
know. It would be no, the p-value is greater than, because we aren't rejecting, we're failing to reject.
No, p-value is greater. Did you get that one, Amanda?
24.
24, yeah, I put no because the p-value is greater than 0.05.
Okay,
Perfect.
perfect. So do you have sufficient evidence to conclude that age makes a difference in whether a person is morning person versus night person? Why or why not? So
I would say since
fail.
the p-value is greater than, that would be, then we'd reject the null. Yeah, so it would be the second to last one. No, because we rejected the null.
Didn't we fail to reject the null?
Yeah, but wait a second.
Because you fail to reject it when it's less than, but it was greater than, so we...
If it's greater, we fail to. I thought when it's higher, we fail to reject. That's why we failed to reject up there, right? So the p-value is greater than 0.05. Because the p-value is greater, we fail to reject. So do we have makes a difference? Amanda, are you there? So what do you think? No, I failed to reject or what? Yeah.
I need to look at it because it's talking about sufficient, and I remember writing down. It says sufficient, then will. Look up sufficient and insufficient and see.
Sufficient and insufficient? Right.
Okay. evidence to conclude that age makes a difference in whether a person. I thought I wrote it down somewhere.
You sort of stop taking. So if you just read the book and start writing it down, you would never keep track of stuff.
Can you guys hear me?
Yeah, we can. Can you hear us?
Amanda, can you hear us? Are you on mute?
Amanda, can you hear us? Amanda? So if we don't reject the null, then we have insufficient evidence.
I mean, if we fail to reject, we have insufficient. Yeah. If we fail to reject, we have insufficient. If we reject, we have sufficient.
So no, I failed to reject the null.
Let me see.
What?
What, son? What?
Hello.
Hey, can you guys see or hear me on Hangouts right now?
Yeah, we can hear you. I just
And
don't
see
think
you.
and see you. I just don't think you can hear us for some reason.
Oh,
Yeah, we're talking.
that's weird.
We're talking back to you, and we're not getting any response. But yeah, we hear you loud.
Okay. Yeah, I can't hear you guys for some reason.
Okay, let's just stay like this because
We're almost done.
yeah, we're almost done, and it's working out.
Okay.
So let's see.
You want me to stay on Hangouts then?
Yeah, just so we still have it recorded.
Okay.
Maybe we'll have him watch our whole thing so he can see how difficult it is being for us.
Yeah.
Then he'll give us credit for the for the last one that we messed up. Okay,
So we're 25.
so we're on number 25.
Yes.
Let's see. I was reading it. So you scroll up.
Okay.
Do you have sufficient evidence to conclude that age makes a difference in whether a person is a morning person versus a night person? Why or why not? We said no because we failed to reject the null.
Wait, wouldn't it be no because we rejected the null because the p-value is greater than?
Reject the null.
Yeah. Well, so when we reject the null, we fail when the p-value is greater, we fail to reject. That's why we put no. Go down. That's why we put no. The p-value is great.
Okay, yeah, that makes sense. Okay. No, because we failed to reject the null.
Right, because we didn't reject it. We failed to reject. So then the 25 will be no because we failed to reject.
Okay, that makes sense.
I hope. Okay, Brittany, do you want to read number 26?
Yeah. A recent book noted that only 20% of all investment managers outperformed the Dow Jones industry average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones industry average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed Dow Jones over a 5-year period.
1.5.
Okay.
So, based on the results of the sample, a 95 confidence interval of P is, well, I don't know what test we would use.
So we know that 20% of all investment managers outperform Dow Jones Industrial Average.
Would it be just a 1? Oh.
N would be 200. Null hypothesis 0.2.
It is.
And then to find X.
Wait, so you said B 200, right?
Yes.
And then X.
We're just plugging in the information here.
We need to find X.
Yeah. So I see to find X like we did last time, you would just multiply N by the null.
Is our null 0.20, right?
Yeah.
So we would go 200. Where's our calculator at, Andrew? 200 times point, and would we have the same confidence interval of 95? And then do we want to know, is it different? Is it less than?
They said investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period.
So would it be just different? Not equal to?
Yeah,
And
it's
then
not equal to.
and then did you get 40 for your X?
Yeah.
I can't get the confidence interval though.
Okay. A recent book about only 20% of all investment managers.
Were you able to get the confidence interval?
Well, I did this earlier and I got C, but now I'm not getting it correctly.
And you put 40 in,
Yeah, 40.
and then well, the type of test doesn't change the interval at all, so
Yeah.
More than one sample t-test for sure.
yeah, it's one
Or
example.
would it be t-test? Or we don't know sigma.
Well,
T-test.
it's a categorical.
Oh.
Well, does it have to do anything with 5-period span, or
With what?
does the 5-period span have to do anything? 5-year period.
Oh, maybe that was it. Wait,
Is that X?
no, wait. Hmm.
Okay, so okay, but it says 50 of these. So would that be X?
Oh, yeah. Okay, X is 50.
Yeah, there we go.
There we go. That's what it was.
Okay.
Then it's C.
Yeah, perfect. So then it says, suppose you have been in charge of designing the study. What sample size would be needed to construct a margin error of 2% within 95 confidence interval? Use the prior P equals 0.2 with the estimate. How did you find this one?
So that one is in lesson 17. We have to use that equation to find N. So it, we have to find out the Z-score.
Earlier when you were talking to Claude.
That was easy.
You walked over and on the couch. Wait, you said it was which from 17?
Yeah, lesson 17. So if you go to lesson 20, review, and then go to lesson summaries, it should show the equation in lesson 17 summary.
Is it the equation that n equals z times sigma over m? No.
It's the second to last equation. N equals z divided by m squared p times 1 minus p.
Oh, okay.
What?
Okay. So
But then I got 1250.3296, but that's not an option.
okay, so you couldn't find a calculator? Oh, where? Here? Oh, okay. So sorry, I'm just barely finding the equation. So if I go 1.768 divided by, and the margin of error is going to be 0.2.
Wouldn't it be 0.02 because it's 2%?
Use the prior estimate of P equals 0.2.
So P is 0.2, but then the margin of error is 0.02.
Okay, so okay, yes. So and then yeah, I got 1252.
Yeah. So I don't know what's going on there.
Did we get the wrong z-score?
That's what I'm thinking. That could be the only thing.
Well, the closest one would be 1537. I'll have Andrew try it too. Here, Andrew. Do you want to try that?
Where's the equation? One, 7, 6, 8. Okay, so we're on 27, right? Suppose you had been in charge of designing the study, what sample size would be needed to construct margin of error 2% with 95% confidence in the use required?
If we change the not equal to, less than, and greater than, does that change our P or our z-score?
No, I already tried that. The z-score stays the same.
This is critical Z. That is
What's our critical z?
critical Z is the you get from the confidence interval. Remember those
Yeah,
numbers?
but how?
Z is right here.
Oh, yeah, the critical z is. Oh, okay, yeah. So we're doing it wrong. The critical z is going to be that point.
It's 1.96.
Okay,
95%.
so 1.96 divided by r 0.02 equals. We're going to square that.
Wait, so the z is 1.768, right?
That's the z-score. It's asking for the critical z. In the equation, it says n equals z with the asterisk. That's critical z. Your critical z, or your critical value is, remember when you have the 90%, 95%, 99%, and
Yeah.
with those confidence, or with those percentages, you always get a significance of 0.1 or 0.05 or 0.01. Remember, and then if it's 90%,
Yeah.
1.645, or if it's 95%, it's 1.96, and if it's 99%, the z is 2.
Oh.
Remember the critical value.
So this one would be 1.96.
Yes.
Okay, that makes sense.
And then by doing that, I just did it. We can get the number right.
Okay, let me try it that way. Divided by... So then did you get 1537?
Yep, perfect.
Okay, cool.
Can you hear us on the
The hangout.
Hangout?
No, I still can't.
Okay.
I can hear myself echoing over the phone, but I can't hear anything on Hangouts.
Sorry.
Sorry.
It's okay.
Okay, so Andrew, do you want to read the next part?
Use the following information for questions 28 to 32. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance, A equals 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing this question? So
it says better than. Would that just be different?
no. That'd be,
No, I think that would be the greater than.
Okay, so then it would be C.
So then it would be C.
Okay.
And then 29 would be C again, because you have to use both those equations.
Okay, yeah. And you want it to be greater than 10, right? Not 5.
Yes.
Because 5 is for the 2 proportion.
Yeah.
Okay. And then p-value would be D, which means it's greater than, so we fail to reject.
whoa, you missed one.
What? Yeah, the p-value is D.
What's your test statistic?
Oh. Our test statistic is the Z, right? So it would be A. And then P value would be D.
Does that make sense, Amanda? Those ones that we were just...
Wait, so for 30 we're putting A 1.768.
Uh-huh. And then
And for the p-value 0.077.
Yeah.
Perfect.
And that's greater than, so we fail to reject the null.
Correct.
So it's the second to last one.
Yes.
Right.
Okay, that makes sense.
Okay, so the only ones I'm worried about are those, like, 2 through 10. But
Yeah.
I don't know. I think we gave it our best effort.
Just a minute.
Yeah, you can submit it. Do you have all the answers now? I think I have all the answers. Did you have any other questions?
No. Have you guys submitted it yet?
No, I'm submitting it right now.
I just want to see how we did on those first ones.
We got a D.
Oh. Was it just with the letters?
Yeah, we got 2 through 5 wrong.
Oh.
And then 10 and 11 wrong. How did we get 11 wrong? Well, that's done.
What? Wait, that doesn't make sense to get 11 wrong.
Yeah.
Maybe that's a test error.
Yeah, because it wouldn't be the possibility of... Yeah, it would have to be that one. So that one's done.
Yeah.
And then we got 13 wrong. So maybe it is chance. But I thought we weren't supposed to use chance. I thought we were supposed to say confidence.
I think it's either A or B.
So then maybe it's A.
90% sample means.
And then we got 14 wrong.
How'd we get 14 wrong?
I don't know, because, yeah, how did we get 14 wrong but then got the rest of it right?
Yeah, you got that one wrong.
And then we got the 16 wrong.
16?
Yeah, but then we got everything else right.
Did we get the other one wrong? Go back to the other one. What's the other one that's similar like that?
Wait a second. So then,
Did we get it?
And we
right?
got 32 wrong.
Oh, that's because this
Oh.
is wrong.
Because we got the p-value wrong. We get the p-value wrong. Oh, because the test statistic needed to be greater than. And we had it probably still at not equal to. So then we got the p-value wrong.
So what's the p-value then?
Probably this one right here. It's
You're just
gonna be-
guessing.
No, it's going to be that one.
So which would be?
wait, we got 31 and 32 wrong?
Yeah, because we forgot to switch the not equal to. We needed to switch it to greater than.
Wait, to greater than?
Yeah, because remember how in 29 or not 29, excuse me, 28 we put greater than.
Oh.
So I
Okay, so let me just go back to that. In that one we had 250, 0.2. So then 31 would be 0.039,
yeah, so
and then we would say, then we would have sufficient evidence. Then we'd say yes because we rejected the null.
and then other than that,
Can we go over the ones that we got wrong?
yeah. So I was scrolling back up. So we got all the other ones right. The next from there, and we got 14 and 16 wrong. So let's read over that problem again. Anna, you want to read it?
You take a simple random sample of 100 results from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportion? I don't.
Maybe it's 70 because it can't be a decimal.
Yeah, that's what I'm thinking. So I mean, your next option is 70. I'd just go 70.
But then our p-value would just be 0.000.
Well, it says, what is the probability that your random sample of 100 people will have a sample proportion less than 0.25?
That doesn't make sense.
Okay. Fine.
And we're really bad at telling which test we needed to do.
Yeah, I don't know what We got 16 wrong, right?
Yeah.
So I don't know what 14 or 16 would be.
Maybe we'll fix it then.
I would just put 14 as 70, I guess. But I don't know what
Yeah.
to tell you to do for 16.
Yeah.
For 13, however, I'm guessing since we got that one wrong, I'd put it as A. I don't know.
Yeah. 95% confident that the true mean is between 10 and 20. Yeah, I'd say A.
That, or it would be maybe C, but I just thought we wouldn't use chance. I don't know. I could be wrong, though.
Yeah.
We don't know.
I don't know either. And then we got 11 wrong, which I have no idea what it would be then.
11. Yeah. What is the... Which one of the following best defines the notion of significance level of a hypothesis test?
Because it can't be B, because B is for number 12.
Yeah.
And then the probability of type
Write
1
that one
and
down.
type 2.
Write that down to email them about
Question 11. So yeah, I have no idea what 11 would be then.
Yeah, I think we should email him about 11, because that's probably a test error.
So,
And then you said we got 10 wrong?
yes.
So then, if it's not a paired, it's comparing the two Oreos.
Well, then maybe they're not thinking that it's categorical. Maybe they're thinking that, I don't know. Or maybe they're not thinking it's quantitative, because we put it as a
Yeah, it's probably categorical. And then that would mean 2 samples.
quantitative. Okay.
So it's probably F.
them.
Yeah, I mean, that's any other option.
Because it's the stuffed and then, the double stuff and then the regular.
Yeah. And then we got 2 through 5 wrong, and I have no idea.
All of those?
Yeah.
2 is H and 3 is G.
Yeah.
And what's 4?
4 we put as B.
And 5. We just switched.
We put as F.
So then, let's see.
So maybe 5 is actually G. We could try it. But if you get that one right, if you put G. And 4. Maybe D. I don't know. I don't know.
Wait, so 5, we're comparing effectiveness of 2 combination locks.
So maybe G.
Yeah, it's probably G for 5. And then,
Mm-mm. I knew it not for the test.
4 we put B. So then maybe it's A. Maybe we are supposed to know the standard deviation.
For number 4.
Yeah.
Or maybe it gives us enough information to find it. You want to put A for number 4? I mean, either way. Yeah, yeah. Might as well. I don't know. Andrew got a C, a 75. So,
Oh, wait.
so switching 2 to H and 3 to G was a right move. 4 is not A, and 5 is not G.
4. Okay, so we're doing a random sample. Heavy players.
So it's not A or B. So maybe it's C or D.
I'm gonna go with the chance one. Isn't it?
So when we're thinking for 13, it's going to be C.
I guess it is the chance one then.
Yeah.
No, that one too.
And
Then
14
so
is 14 isn't 70.
what?
So it must be, maybe P is the mean, so maybe it is 0.03.
That's weird.
Um, 16, and it didn't change, so.
You're supposed to.
No, I don't know. We don't know either, so.
Okay, well, I'm just gonna submit mine and see.
But then he did get 31 and 32, right?
Okay. Let's see. So 2 was H, 3 was G, 4 is not D,
Okay, so I wonder.
and then 5 I still put G, so that's wrong. Got 10 wrong. 11 wrong because that's probably a test typo. Oh, I got 13 wrong. It's not A, B, or C.
So it's D, really? 95%?
What?
95%.
But that never was an.
Yeah, I thought that it was never that.
Yeah, it's never that. There has to be a test typo.
We are 95% means exactly.
It's never been that when we've taken tests with that same question.
Well, I guess maybe it's because it's talking about a confidence interval.
Maybe.
I don't know. That's weird, though. Did you get 14? Did you switch 14 at all?
14, yeah, it is 0.3.
Okay.
And then 16 I got wrong. I don't know if I changed it. I put 0.876.
Yeah,
think I
that
did
you didn't
change
change it.
And then,
And then, but you switched the other two, right?
yeah, and then everything else is right.
Okay.
Okay, well, hopefully the test goes better.
Yeah. Oh, darn it.
So then, do we want to meet at all for the group thing, or do we just want to email back and forth?
We can just email. Is that okay?
Yeah, that's fine with me.
I'm sorry. I just don't know when we'd be able to meet.
Yeah, that makes sense. So then, if you guys could just email your data that you collected last week to me tonight, then I can do my best to get the assignment for this week emailed to you guys tomorrow.
Okay, perfect. We'll email that right now
Okay.
as soon as we get off here. And then I will email him about question 11, and I will send him the group link for reading.
Okay.
So,
Okay, sounds
alright.
good.
And then we'll meet again on next Tuesday.
Yes. And then I'll be the group lead next week.
Okay, perfect. Sounds good.
Okay. Thank you.
See ya.
Bye.